Oh, a very good morning to the viewers of this Russian CSPA conference, and also my fellow participants. So, in this my project, my paper is about an automatic system design implementation. So, in this presentation, I'm going to present more about my project and everything. So, so the problem statement. So, the larger garden or whatever the garden we are having in our home or wherever, there will be more work needed to irrigate the plants, and also it's very time consuming activity, require more manpower. We have to need one or two men to take care of this garden properly, and also sometimes the gardener who are working there always uses the manual way to irrigate, which is use the normal pipe to for water the plants, like in the picture. So it's not what I'm saying is not effective. It creates over irrigation. The gardener may plant more amount of water compared to whatever the plant needed the exact amount of water. So this over irrigation occurs due to the bad distribution of the water from the gardener. So the objective or the idea of this project is to design an automatic irrigation system that are able to provide the plants within the needed amount of quantity of the water based on the feedback from the moisture and temperature sensor, and also to implement the automatic irrigation system and the management and science system, the farming garden with the monitoring system to a mobile phone application. So the scope of the project, so basically the system, irrigation system, properly detects the moisture and also the temperature level of the specific plants, and the water will be supplied to the garden from the water pump, and the valve will be open to irrigate the plants based on the feedback from the moisture and temperature sensor. So the mobile application will give the full monitoring system and also a manual control system for the user to take care of the irrigation system. So the significance of the project. My project is based on the Sustainable Development Goal number 9, which is Industry Innovation Infrastructure. It is build the resilient infrastructure, promote the inclusive and sustainable industrialization and foster innovation. Basically, to explain more about significance, it increase the water efficiency, and also the labor required will be reduced to take care of the garden, and also it's easier way to irrigate the plants. So this is my flow chart of the projects. Basically, after it started, the soil moisture sensor and the temperature sensor will check the moisture and the temperature of the soil, and it will send the signal to the microprocessor that have been used is Arduino Mega 2560. Once it receives the signal from the sensor, started do the process. If the moisture level or the temperature level is less than the threshold value which has been set, it will send back the signal to the microprocessor and give the command to the water pump motor and also the electrical valve to do the further procedures, like the valve will be open, and also the water pump motor will pump the water and will send the water, and it will irrigate the plants through the electrical valve and the pipes. If let's say it's say no, if the threshold value is more than, if the moisture level and temperature level more than threshold value, it's sent back to the sensor, not give any other command. And also there will be another process will happen from the microprocessor. It will send the signal to the Bluetooth module. Will receive the signal and we send the signal to the Bluetooth module, and we will from the Bluetooth module we can go to the mobile application. We can see that we have two systems. One is a monitoring system and also a controlling system. Monitoring system, it will basically show the temperature reading and the moisture reading. And the controlling system, it will send back the signal to the microprocessor to the power on, power off to the system if let's say it causes any error or over irrigation. So the block diagram of the project is the input, like I say, it's a soil moisture sensor and also temperature sensor, and the middle is the microprocessor. Will do the processor, will do the process, will do carry out the all the process, and the output is a water pump motor and also the electrical valve. And the outside, which is the power supply, is very important. Will give the power supply to the microprocessor and all the other moisture sensor and also the water pump motor. And it will be a Bluetooth module and a user face interface, so we can send mobile application have a dual process. So this is a circuit simulation. So we can see at the left hand side there's a temperature sensor, soil moisture sensor. It will be an input to the microprocessor, which is the Arduino 2560. And also the output, we can see the monitoring system and also the valve, electrical valve we have been using, valve 1, valve 2, and also water pump motor. So this is my project design. We can see clearly there will be an electrical valve at each row, and also the water pump motor, which is half horsepower water pump motor, and the soil moisture and temperature sensor. Each row we have like three to four soil moisture sensor, and also the temperature sensor. And also each row have a electrical valve for each row. It's another view of my design. You can see. So this the results and discussion. The results is basically for when we have a test system. So we can see the moisture sensor is choosing the negative 30, negative 6%, negative 13%, negative 25%, and basically it's on the relay, three relay which is connected to the valve, one valve, two valve, and also the for the water pump motor. So this negative 6%, negative 13%, negative 25% shows the soil has been dry. So that's why it's showing the negative percentage. Once it's called the moisture rating before the watering the plants. So the next photo shows the moisture rating after the watering the plants, which is already the soil has been received a good amount of water and it's not dry anymore. So this is my replica of the project, which is like it's not the largest scale, the smaller scale. We can see the circuit, and the moisture sensor has been connected properly, and also the pipe connection that I've been did. So this is like the exact the largest scale of the project. Just now I showed the replica. This is the largest scale. We can see the real water pump motor has been connected and the electrical valve and the big circuit box, and connected more than like I mentioned, 3 to 4 sensors for the row in each row. So this is the mobile application I've been using for the automatic irrigation system. We can see which is the reading, the line wall. At first line I used the black soil, and another one I used the burnt soil. We can see the moisture reading and the temperature reading. Moisture 1, temperature C1, moisture 2, temperature C2, and also the second, we can see another 3 set of sensors, and also the variable system that I used to on and off the each valve, and also the system if let's say have any error to show error happen or over irrigation occurred. So to explain more about the discussion, the process, we can say like I can explain through this slide. After collection of this all the component, first of all, the system has been tested properly to complete the overall irrigation system, and the results became as required. So just now the photo I shows like the moisture reading only. The results happen. The results shows during the system testing, not exact result. The application I've shown is like shows with the moisture reading and also temperature reading. So the system basically, the system will not work until any other multiple moisture sensor, temperature sensor from any row send the signal to the microprocessor that the soil are dry, like I mentioned before, and it commands the relay for the specific line to open the valve, and command the relay that is connected to the water pump to directly to irrigate the plants. And both rows can irrigate at the same time. If let's say one or two moisture sensor activated, not necessary all the three moisture sensor or four moisture sensor in a row has been activated, then only it will open the valve or activate the pump to irrigate. Let's say it's like just one or two sensors of this moisture and temperature sensor. If it says saying the soil is dry, so it will open the valve to irrigate, because all the sensor has been set in the same line, also receiving the same amount of the sunlight light. So we can say like one of the sensors receive at a negative or negative moisture reading, also lower temperature reading. It's like everything is same only for the each row. And then all sunlight valve relay to energize to open the valve, and the pump will run to irrigate the plant, like I mentioned before. The wire connection of this Arduino has been very difficult. Very difficult. If let's say if any single mistake can damage any electrical element, connecting the wires like more than 10 components, I can see the more than 10 we can have like multiple sensors. Each will have a 4 to 5 temperature moisture sensors, the water pump motor, and also the relay, the wire. It's like very complicated and very hard to do this project. For designing this plant, with for designing for the water pipe, flexible pipe, and also when used to facilitate the connection from the water tank to the plant, and also face a lot of problem due to connecting pipes together. For the replica, I've been used the flexible pipes just so to make it simple. But for the larger scale in the garden where I'm using, I've used everything like the proper PVC pipe to water the plants from the if we connected to the from the water pump motor to the electrical valves. So to the conclusion, during this project, many problems were faced because the project size is larger scale compared to the replica to setting the gutters like very difficult. Like I said, the more than 10 component were connected to the Arduino wire connection has been complex and it's very hard to connect. And controlling the Arduino quite challenging because of single mistake can damage highly electrical. And also doing the programming was very hard. Doing Arduino code is to build the system for the irrigation system. It's like kind of hard, but as long but we're still able to complete the project with expected results. And thank you so much for listening to my project. Just hoping for best to happen. Thank you.